Welcome, everybody. Well, first, I wanted to thank AIA for hosting us and allowing us to have our event here. Thank you, Mark. Thank you, Erica. And thanks to Autodesk for sponsoring the event, making it free for members and students. Well, Playable Architecture. I didn't come up with this name. ChatGPT did. I said I'm doing something, it's Unreal Engine and it's game, and what do I call it? Give me 20 options. And it was like, Playable Architecture. I'm like, yeah, this is the one. But I chose it because it represents exactly what I wanted to present. But what does it actually mean, Playable Architecture? That's a question that I don't know the answer to, but we're going to find out together. Because from where I stand, this could be playable architecture. You can just build stairs and then go up and shoot, or you can create a home and live in it. Or it could be something like this, that you just change a material on a building that you already designed and you have walkthroughs, you get to walk around and experience it, or just purely use it for visualization, making changes to time of day, interact with your building. That could be a game, but a very boring one. But still, it's a game. You can do stuff. Now, we face one issue as architects, and that is we have many models sitting in our computers that nobody knows about. They're just sitting there. They're alone. No one knows about them. No one can explore them. They have been done like 10 years ago. Even at your company, people don't know about them. They're just there. Revit knows about them, but that's about it. Now, what's stopping us from just grabbing that model and import it to Unreal Engine? We'll get to Unreal Engine part, but import it there and hit play. Why can't we do that? No game developer company has ever produced a model as detailed as the models we do. We think it through. It's an actual building. For them, it's just the representation of some space and you get to walk in it. But our buildings are actual buildings. How come we cannot just shoot it there and hit play? What's stopping us? There is something that's stopping us, and we'll get to it. Well, first, there's a disconnect between our industry and gaming industry. And that is, we speak these different languages. Anyone who's ever played any video game knows that if you get close to a door and you hit E, it opens it. But that doesn't mean anything. It doesn't mean anything in architecture. But for gaming people, it means something. It means there's a mesh and there's a code attached to it. That's how they see it. For example, this corner of two walls and a floor. For us, this is what we see when we look at it. Well, what's inside it? The structure, the studs, the gypsum, whatever it is. We see it as it is, and it's going to be built. They see it as a mesh with a UV map on it that's a texture, that has a texture. That's how they see it. So this is a big difference, and it starts to add up because you remember I told you that we have models that are super detailed? That's exactly why we cannot shoot them in. I'll show you why. But before that, I need to take a detour. Let's talk about data a little bit. Data is just information for computer. It's stored and read by computers. And for us, for example, this, we see it and we're like, oh, it's a wall. What a computer sees, it's just code. Especially if you're saving it as like an FBX mesh, it's just code. It's points in space that are connected to each other by faces. But you look at it, you have a meaning for it. You're like, this is a wall. Now, There is another concept, metadata. That's data about data. Because data has data. If you buy a book, there's a novel, but that novel has information. There's an author. There is the date it was published or whatever. So there is information about that novel. Same goes for us. That wall, that's a point in space, comes with a bunch of information. The wall type, the material, the author. In this case, is Shervin. Shervin right here. But the point is that computer also sees this. So it creates a representation of the 3D object for you to be able to visualize it and for it to be able to store it. But it also attaches information to those information, that's metadata, that both have a meaning for us and for it, but it restores it. The point is that it stores it, especially with Revit, but you don't really have access to it unless you ask the question. If I ask Revit, who made this wall, I can see who made it. But if I don't ask it, there's no way to know. So it's a Q&A type of deal. So that brings us to the next part, that's data extraction. How do we extract data from these softwares? Well, let's just compare Rhino and Revit because they're widely used in our industry. Rhino as a software that treats everything as geometry. Anything you do is just geometry. And the geometry has colors, has layers, has information, but it's geometry. But Revit doesn't do that. So let's just take a door, for example. For Rhino, a door is just a poly surface with a layer, with a bunch of faces and materials and mesh count or whatever it is. It's just information, it's just visual geometry information. Now the same door, well, not quite the same door, but same door in Revit has everything except for visual information. I mean, it does have the visual information, but when you ask Revit, what is this door? It doesn't tell you, oh, it's a mesh that has this many triangles. No, it tells you who made it, who's the vendor, what's the category, what's the model family, and how much it costs, what's the material on it, and a bunch of other things. A lot of information, and we all use this information. Your team is using this information. Your interior model people, if you have interiors, they use the type key to document everything, to have like schedules and buy stuff and show it to the client and everything. But you don't know about it because you're not asking the question. You're asking something else. You're asking about the visual aspects of it, or if you're rendering it, you're asking about the material. But the point is, there are information there that you are not seeing because you're not asking for it. It starts to make sense. Be patient. This is just a project in Revit, visual aspects of it. Now, if you've ever worked in Revit, you know that's, well, yeah, this is the geometry, and you get to explore the geometry, and it shows the geometry, and it saves the geometry, but it also saves the schedule. And whatever you want to put in the schedule, you can, and you'll have access to it. But for example, a room has a department, has a square footage, has a lot of information, but you don't really see those information, do you? It's stored somewhere, and if you print it out as the final product being printing, you see it, but you don't have access to it. Except if you export that information and use a software that reads that type of information, like for example, in this case, I brought it to Power BI, you get to see it, and you get to see the information that you've been creating, your team has been creating without knowing. I get to click on different parts of the building, different parts meaning like different departments, different levels, and see what Revit has stored, how much square footage is in that department. Now, why am I telling you all this? Because that might be the one thing that architecture, playable architecture can have that nothing else will have. Because if you just create a walkthrough and walk through a building, congratulations, you just built a very boring game. That people are just going to walk around and you think people are going to admire your design. That's not how it works. If you want to represent the visual aspect of your building, you can just make renderings. You don't really need to do all this work. Why would I do this? What would justify a lot of work to make a game out of your design? It's information. It's extracting information. Now, the detour ends here. We're going to get to the gaming part and what you came here for. Just have to create the foundation so we can talk about the same thing. Let's compare architecture industry with gaming industry. If you've ever worked in any architecture software, you already know everything you need to know. It's just a different language. They use different terms for what we use. Meaning like location and rotation together mean transform. Unreal Engine calls it transform. Families or instances or blocks in terms of Rhino, all instances. Tiling in Revit is UV map, and etc. Now, we talked about this part. We look at the wall, we see this. This is a wall to us. Game, look at it. It has to be clean mesh. It has to have UV. It has to have texture map, normal map, reflection map for it to look good. That's all they care about. Even when we work in 3D, when we look at this, we see a scene, a collection of some elements, furnitures, fixtures, specifications, vendors, details, pricing, material. What they see here is really just a bunch of meshes, texture maps, light sources, colliders. That's what they see, because that's what matters in gaming world. Why is it that they focus on these type of aspects of a scene? Is because it's going to be more demanding. The more faces, the more mesh you have in your scene, it's going to be more demanding on your computer. It's not going to run smoothly. And for us, the final product is our sheets. We just give it to the contractors or consultants and they build the building, or we build it. But for them, the final product is your experience. It's how you feel when you're in that building or in that environment. And so they have to come up with methods instead of using high number of meshes to get a smooth result. That's how they look at it. They want to have the horse head, but they don't want all these faces because that's never going to run. They want that to become this. And there are techniques that do that. For example, this like shade smooth technique it just renders it differently. It's the same object, but it renders differently. That's how they handle it. They lower the number of meshes while showing you the same product that you as an architect draw curves and stuff on. So they come up with techniques. They also bake lights. Baking light is essentially, I'm just going to read it off of here. Baked lights means pre-calculating how lights and shadows fall on surfaces and saving that information as a texture. This way, the scene looks lit without needing real-time lighting, which makes it run faster. So all that being said, they optimize. That's the difference. That's why you cannot bring your model into Unreal Engine and hit play, because your model is not optimized. You have structure, you have piping, you have screws in your furniture. That's just not going to work. It's just not going to work. Well, that's not the only obstacle. The other obstacle is, I talked about it. The only obstacle is that, but not really. There's one more obstacle, is that our work is always in progress. You're changing your design up to like the last minute. But fortunately, Unreal Engine solved that for us. They came up with this plugin called DataSmith that your Unreal Engine 2024 already comes with it. It allows you to extract all the information and have a live link, and it's good. you can read about it later. Now, we have the models. We are going to optimize it. All we need to do is to add context, because no one wants to walk around in a building without a context. That's just doesn't look good. And we need to collaborate and have a live link, meaning you will not be able to do everything by yourself. You have to utilize everyone's work. And this is very important because the process of creating a game is very time consuming, and it's not going to fit in your project timeline. And if you cannot make it work in the project timeline, you will never have anyone sponsor you doing this. You have to make sure that you utilize everyone's work so you don't have to redo any of it as much as you can, so that you can focus on the part that makes the game run. So first things first, we have to chop up the file into smaller pieces to bring it to Unreal, because that way we can optimize it. And that means that if you change a part of the file, part of the design, you don't have to re-import everything back in. This is a project that we worked on, and I'm just using it as an example. I chopped up the file this way. You can do whatever makes sense to you. Doesn't have to be this, obviously, but the point is that you need to break it down to smaller pieces, put things that don't change separate from the things that change, so that you can lock them. You can even bake lights on them later on. And then, well, obviously, you meaning, yeah, well, this is the building. And then the furniture, for me, I separate the furniture because interior team is different. Well, in this case, wasn't. All of it is showing, actually. But then there is MEP, the trees. The trees are dummies, placeholders, because Unreal gives you the option to just replace everything at once, which is really cool. So utilize everyone's work. Same project, we were working with landscape architect, and they work in Rhino. And they also use Twinmotion, not Unreal Engine, but Twinmotion to render their file. Meaning they already put all the trees and landscape and grass and details and materials there once. And then it wouldn't make sense for me to just go to Unreal and do everything again. That's what I mean by try to think this way. I'm going to utilize everyone's work as much as I can. I'm not going to redo. And fortunately for us, Twinmotion is just a kit of Unreal Engine. So you can just ingest that file. Whoever you're working with, that they are working in Twinmotion, they're giving you a gift of time, because you don't have to redo anything. Now, another part of it is context. Again, you don't have to do anything by yourself. And this is a different project because for that one, we didn't really build a big context, but you can outsource your context because context exists. They can just look at Google Map and create context for you. And if you outsource it to another country who you can get it cheaper, then you save time and money. You don't have to do everything yourself. And this way you get to have like high quality, high detail model that Unreal can ingest. And gaming people, game developers are really good at doing this. They do it, they are very optimized too, because that's what they do. That's how they think. But this model is not actually that heavy. Now, I don't really need to say this. I think everyone probably knows about this, but Unreal has a big library of materials and characters and cars and players. Everything is ready for you to just hit import and run it. Some of it are paid, some of it is free, but the point is that if you know nothing about coding, you can still create a game for free, because a lot of these are free on their website or come built in Unreal Engine. But in this case, you can just download one of their materials and keep changing the texture map and create your new materials. because the brain of it is already made by Unreal. Now, let's get to Unreal itself. At first, you look at this and you're like, this is very overwhelming. It looks like an airplane cockpit. I mean, if you click on each, and each window has 10 other windows in it. And I don't know what to do. I don't know what to click, but it's very simple. The amount of knowledge you need to have to start working is simple. There's the content browser, and content browser is just showing you the folder that you have Unreal Engine installed on your computer. It's the same folder. So anything you put in that folder is going to be reachable for your software, for your game. That's what it means. If you want something to be used, just put it in that folder. And then you have this outliner here. That's everything in your scene. So what you really are doing is you're grabbing things from your content browser and putting it in your outliner so you can see it. Because if it lives in content browser, it's reachable, but it's not in your scene. And then you have like the standard, like different type of rendering, like wireframe and shaded and unlit or whatever, and a bunch of other things. You can explore it on yourself, on your own, but the point is that the first page, this is all you need to know. That's it. Then you bring the file in, you need to manage your file. That's the second part. And Unreal has levels. Levels, they use it in gaming industry, they use it for levels of games. So it loads whenever you finish a level, it loads another level, right? But in architecture, we use it as layers. This way you can have your different options on different levels, and it gives you control to turn it on and off. So you just bring everything in, put it on different layers or levels in this case. That allows you to see what you need to see in each view or not see. You can animate it. You can have options. And the way that works is that, like, this is the interior level. And it's dark because there is no sun in this level. There's a master level that has all the sun and light and camera and everything, and it loads all the other levels in it. So this level doesn't have a sun, so I cannot see it, but it allows me to just go in, make the changes, replace it. If it updates, update it, and then go back to my main scene and see what actually needs to be seen. That's file management. And then now, this part, I'm just opening doors for you. These are the questions that you need to ask Unreal. These are the keywords that you need to look for when you start your first project. These are the things that you need to deal with. This is not a tutorial. Like, this is too overwhelming to be like a tutorial session in half an hour, you start Unreal. But you'll know there's not much that you need to adjust for your scene to work. There's like 7 or 8. That's it. That's all you need to know. And your model starts working before you can, like, much faster than you imagine. That's why I included this part. Materials. There's 2 types of materials. There's a master material and then material instance. That might be confusing, but material instance is what we as architects like. It shows you roughness and everything, and you change it. Material master is this. That's like the one that everyone is trying to avoid because it's shading. You have to do grasshopper stuff for it to happen. But the good news is that those parts have already been done, but so many people, you can just download one material, and this is what you will be dealing with. The normal roughness changing, metallic changing, the things that you're familiar with, because these materials already exist and someone has made it. The point is that you don't have to do everything from scratch. It exists. And one thing that you need to know is Unreal Engine uses these terms: static mesh, skeletal mesh, control rig, blueprint class, and it's a bit confusing at first, but I'm going to just open the door so you know which one is which, and then when you start your first project, you No, yeah, you don't need all of them, but based on your project, you can decide which one I'm going to go for. So static mesh is just the mesh. It just calls it static mesh. It's the object. Like a car comes with a bunch of things. Those are the materials that are on the car. This static mesh. This is just the geometry data, and as you can see all the materials here, I can just replace all the materials with whatever I want, and it will show up. And then there's the skeleton of them, meaning if you've ever done any animation, it just connects the different parts of the mesh together as if like our skeleton. It just binds them together. And then controlled rig is the code that sits on the skeletal mesh and allows you to move it however you want. Allows you to code movement into the bone of your mesh. And it allows me in this case to like just connect the wheels to this arrow. So whenever I move the arrow, the wheels move. And that matters because when you're trying to animate something as like a car, wouldn't it be nice if you don't have to animate it, if it's just smart and it just responds to what's happening around it? That's the power of Unreal Engine. Instead of you starting to animate every little thing like any other software, it's just smart. It just does it. And instead of you animating, you create a game and the game just has the physics of the world. And then you get to film part of it and make an animation if you want, which is the next part. But the point is that having a physics that work make everything easier. Now, that was a car example. Let's just talk about this. The door on the left doesn't open. The door on the right opens when I click on it. The floor changes when I click on it. Wall doesn't. Or back here, that gun changes to this, but the table, nothing happens when I click on it. The only difference between these two is one of them is a static mesh, one of them is a blueprint. The door on the right is a blueprint. Blueprint is a code that's attached to your mesh, to your visual data. So when someone clicks on it, Unreal knows how to react because there's a code. There's something that responds to your click. But it also has the static mesh data. It has the visual data. That brings us to the next part, colliders. Another thing you need to know, mesh doesn't collide. Mesh doesn't mean anything. It's just a visual information. The box on the left has collider. The box on the right doesn't. It doesn't collide. It's very simple. If you don't put colliders on your objects, you cannot click on them. They don't collide with anything. They can just clash and nothing happens because it's not recognized as an object. It's just recognized as visual information. Now, your collider doesn't even have to look like what you have. You can have a box and have a sphere collider on it and have it roll on the ground, which would be weird, but you can do that if you want. Now, this is one of the most powerful tools that Unreal Engine gives you. It's called Nanite. Nanite, you just need to know it exists. So sometimes you're rendering something, you're like, oh, it doesn't look good, I don't know what to do. It's probably because of Nanite. Nanite only renders what matters to it in terms of optimization. So the tree, when you look at it from up close, it has details, it has all the leaves and everything, but the tree in the back doesn't have it. Why is that? They are the same, these two are the exact same tree. Am I playing it? Yes, I am. But it's not moving, is it? Okay, there we go. The tree in the back, yeah, but as soon as I get close, it loads. That's Nanite. Nanite only renders what you are seeing in your scene and is close enough that matters. It allows you to have a massive scene full of little objects, but not crash. I know, I told you you need to optimize to bring it in, because if you don't optimize, you're walking on that land. You're not walking on this tree. This tree doesn't matter. But the land that you're walking on and the detail you're going to show your client, they matter. So you better optimize those. The things that don't matter, Unreal Engine will optimize for you. Don't worry about that part. Now, imagine you create your scene, you set up everything, you optimize, and your scene exists in Unreal Engine. But now you want to make actual output. Before even you get to your game, you want to create renderings, videos, animations, whatever it is. You need sequences. Sequences, if you have worked with any other mesh software, it's just keyframes. It's just keyframes so that you can animate your camera, your objects, your colors, your materials. The difference it has, the different sequence have with keyframes is that you get to change properties of an object too. Like I can change the material of the sidewalk there. So I can just go in and change almost everything about an object in an animated manner, so that I just click run and everything happens on its own. It could be movement, it could be properties. That allows you to create animations, right? Or even like, if you're a gamer, sometimes you're playing a game and then some demo happens, like the character starts walking and talking to other people. That's what it is. That's how they do it. Sequences. The next part is game modes and characters and NPC characters and everything. Everybody knows what NPC is. Non-player character. There's actually a syndrome called NPC or NPC syndrome. Do you know about it? Yeah. Means that everybody else is non-player character except for me. I'm the main character. That's the syndrome. Which, in this case, is actually true. You're the only player. Everybody else is just there to support you. When you create a scene in Unreal Engine, you get to experience it however you like, because you get to change your player. I can play it as a third person called Lexi. I can play it as a third person as a robot. It doesn't matter. I just change the avatar. The point is, when you create your game, you can experience it however you like. You can be a camera that can look around and fly. You can do it with VR. You can put AR on it. You can put it on your phone if it's light enough. Because these characters already made by Unreal Engine, they're already coded. You get to change the avatar to whatever you want. The code is already optimized. Everything is done for you. All you need to do is to tell it to use it and then hit play. And it, even out of the box, it comes with all these. So you can decide, I'm going to make an AR app and then run the AR template and then bring your building and hit play and it will become AR. And I'm not joking. It will become. All you need to do is to optimize it. Because AR, you're going to run it on your tablet and it's not going to open your hospital. It needs to be small, manageable geometry. And my favorite part, God mode. In Unreal Engine, you have control over everything, and that includes the weather. If you want it to rain, it will rain. If you want thunderstorm, is it raining? It should. Oh yeah. If you want thunderstorm, it happens. Sandstorm. And this is a plugin. This is a paid plugin. It's actually expensive. It's $150. You don't have to use the plugin. It's just so good that it saves you so much time. You should use it. But this you can even use in your game. So the weather can be controlled within your UI in your game. It even responds to like the mesh on the snow. It's very smart because physics apply in this universe. Makes it super easy to create believable content. Now, all of it is for us to create believable content. I'm just going to show you a walkthrough of the context that I outsourced and the building that's there. This is, it's not out of the box. I had to apply materials and stuff on it, but I didn't spend as much time as you think I did, because most of it was done by putting everything together. It's just a matter of getting the right lighting and some material fixes for it to look pretty realistic. And this is, you probably know what this is if you live in LA. Do you know where this is? No? Okay. Yeah, it is. Now, the result of everything that I showed you is in the next slides. And I'm going to be honest, I think I should have put more material on that part, but I had too many slides, so I deleted it. But I have a little bit, and you get to see how you can navigate the building that we made. You can, well, I'm running the game, so people are walking around and even reacting to each other because they're smart. And they don't even know I exist because I'm a camera. I'm just walking around. But it lets you create a believable working environment. This is a school, and everyone is doing their thing, walking around, playing on the field, and you get to capture moments of it. And you don't even need to animate it because your client or you can just walk around and see it happen in real time. Or I'm going to change the player to a first-person character that walks around and interacts with objects. Yeah, like I can add an interface to change the time of day. Obviously, that's basic. But my favorite part, and the reason I took the detour, is this. I get to click on this column and see how many of it I have in my project, what's the material on it, what's it called, and you name it. Whatever it is that you want to extract, you can extract. I can click and show my client, oh, you want to know how many of these doors I have? Let me check. I click on it. Or they click on it. You can just send the file over. I think what's important, what in this playable architecture is that our game, the game that architects can create but nobody else can is this. I can extract information, actual information, and this might be even a building that's already built. All because of this, because you remember DataSmith that I told you, the plugin? It gets everything. It extracts everything from Revit. All the metadata that comes with one object, everything you can think of is here. So technically, you can create schedules here. I don't know if you want to do it in Unreal Engine, but you can. But you can visualize it in a way that nothing else can, because it's just a realistic walkthrough. It's a game. It's much more relatable. And I found a bunch of examples online that makes my examples look like gameplay, like kids play, but I'm still going to show you because they're cool. Like this one is for real estate, and they created this so they can, I'm guessing, sell this building. So you can click and see, I don't know, the interiors, or like go to the lobby and change the layout of the furniture in the lobby. And I believe there's another example of, yes, this is like I think a city block that shows you what's in your proximity, like what do you have. It's being used to market, or like, I don't know, like it's a real estate tool for them, because these are buildings that are already built. You can see all the amenities and everything. And yeah. Oh, it shouldn't be like Now, Unreal Engine to start is very overwhelming. But the good news is that you can start in Twinmotion and just shoot it in Unreal. Briefly talked about it in another slide, but this is a time lapse that shows you that it's really fast and easy. This is Sketchfab. I just downloaded this model as a 3D model. And this is the amount of detail, and this is what it is. I just downloaded it as FBX, shoot it to Twinmotion, and this is a time lapse. Just I'm not gonna talk over it, but we can watch it together. Just applying materials. And as you can see, everything is drag and drop. Twinmotion is very user-friendly. It was made exactly for architects who don't want to deal with Unreal Engine. Has a massive library of vegetations and cars and people and everything. And it's fairly easy and fast to create a believable scene and render it in like ray tracing. Pretty good result. Now, I just grabbed this file, export it to a format that Unreal Engine reads. You can look it up, and I just import it. At first, Unreal is loading all the textures, but once it loads it, it just becomes the exact same thing. Now, those things that the trees in the back are nanites. That's why they doesn't look good. But when you render it, it looks good. What I did in Unreal Engine was just nothing. I just imported the Twinmotion file. That's what I did. Meaning that if you don't want to deal with everything that I talked about just now, you don't have to. You can create it in Twinmotion, bring it in Unreal. You might ask, why would I bring it in Unreal if I already get that in Twinmotion? Yeah, you don't have to. Except you cannot make a game in Twinmotion. You can only visualize. You can only render animation. But if you want to interact, you bring it to Unreal, and on that scene, you just add a player. That's it. You walk around. You don't get to open the door yet because you didn't add the code to it. But once you do, which is not that hard, then you're good. Yeah, you weren't supposed to see that one, but yeah, that's it. It's time for questions that you might have. Yeah. Oh, that's just for our recording, by the way. You're not gonna hear it louder, unless he speaks louder.
Yeah. So the question is, how big are the files when you import it? So I have a Revit model. It's already big enough. So when I bring it into Unreal, is it even bigger than the Revit model, or you can still suppress it someone, or what is the?
What is the Unreal size?
Yeah.
Very big.
If I need to show it to the client, probably if you send it on a cloud.
Well, no. You're asking two different questions, though. The Unreal file is big, but if you create a game, that game file is not that big. Because Unreal file has all the engine and everything that makes it possible. But once you export it as an executable file, then depending on how big your file is, how much texture map you have, the size varies. It could be 100 megabytes, it could be 80 gigabytes. You're not gonna hit 80, but it's a big range. It's a game. Yeah. But if you have a big Revit file, you're gonna have a big Unreal file. So you better optimize it. Slightly, in order to make the game, you need to be slightly stronger, better hardware. Yeah. But running it, well, do you play video games? So you know how you can change the spec, and that also exists here. So when you make the game, you need a good computer to make it, but then you get to add those specs and allow them to decrease the resolution or whatever it may be so that it runs on their machine. Or you can even do it for them and send it over with a smaller file. Because one of the biggest factors in how big a file is or how smooth it runs is the texture size. Not what you expected, but that's what it is. Because a 4K texture or an 8K texture, one cube is 100 megabyte. So imagine if you just use the texture for your whole space, it's going to be really heavy, right? Now, you don't need to see everything in 8K. That's just nuts. Your eyes cannot even see it. That's where optimization come in, and Unreal is really good at that. I usually just use 2K. I don't think you need more, 4K max. And then your file gets smaller and smaller. If something is up there, I don't really need high resolution texture.
Let's say
Oh.
What you think would be the best way to just like put work sets of the layers and then
You're not going to make changes to anything.
like if it's something that's like completely yes.
I would still highly suggest DataSmith, because it's not just the fact that it allows you to have a live link and it gets all the metadata, but it also was made to optimize geometry for Unreal Engine. Now, FBX is a good format and it always works. It's very reliable. And if you have something that's already in FBX format, by all means, bring it in. But if you're exporting from Revit, Revit doesn't even have a good FBX exporter. When you export it, it loses all the material information, so you have to redo it.
I was wondering, like, you didn't need all the plumbing, all the plumbing that into rid of it and then have it separate later, but I guess
You don't need to have a separate model. You remember the part that I was chopping the...
Yeah.
That part is just views, because DataSmith or anything you're exporting from Revit, you just create a view for it, right? So you create a view that doesn't have the pipes and export that.
Does any type of visualization software work, or does that between? Have you found the results?
The Lumion is dead end. Nothing, you cannot ingest it anywhere. But let's say like 3ds Max or C4D. Those can be imported. You have to import it as FBX, but those softwares are intelligent enough to bake your materials to your object. So when it comes to Unreal, it looks good out of the box. It can look better. It will never reach to emotion level of no touch at all, but it comes in with materials that have texture maps, all the maps that need it. Even in terms of like Maya, it comes in with material instance that you get to change the roughness and stuff because it's smart. But I don't know, if you're bringing something from SketchUp, it's just going to be the geometry, maybe the texture on it. It depends how smart your initial software is. Yeah. Mm-hmm.
So I'm like really good at Rhino, I'm good at BIM, good at Photoshop. I know nothing about what you talked about as grasshopper stuff.
Mm-hmm.
And I started using Twinmotion recently. And I think it takes like a day to like start making awesome visualizations and everything. And I'm wondering, what's the advantage to, like, should I learn how to use Unreal? Like, what am I missing out with just using Twinmotion, not Unreal? And does it have to do with the grasshopper stuff? And if it's the grasshopper stuff and I refer to it as such, should I start by learning grasshopper, or is there some other fundamental thing about coding HTML or whatever that I need to learn? It's like these boxes with information and tentacles between them, totally foreign to me.
Yeah.
Which is really funny because I graduated somewhat recently, but I feel like I'm drafting a graphic table with Mainline all of a sudden.
Yeah. I totally get your question. And first, what are you missing on? Interaction. You don't get to click on anything into motion, meaning a walkthrough. If you export a walkthrough, which 2Motion allows you to do, you can even have VR out of 2Motion, believe it or not. But in that VR environment, you don't get to open the door. You don't get to click and see how many of these chairs you have in this project, or etc. So that's what you're missing on. Along with better render quality, Unreal is always 10 steps ahead. They first, because it's the same company, it's Epic Games, they first do something in Unreal, and then a year later, that makes it to 2Motion. So you will always be behind. Now, the second part of your question, do you have to do the Grasshopper stuff? I just refer to it because in our industry, everyone knows Grasshopper, but it's not Grasshopper, it's actually C++ codes. That works the same way in that sense, in the sense that you just connect the input and output of a block to another block and it responds to you. So you don't have to code everything from scratch, but you definitely need at least a basic understanding of coding, if not more, to create those. Now, do you have to create those? No, not really. Because as I showed you, like depending on what type of interaction you want to have with the environment, if you just want to walk around and have a player and change the time of day, you don't have to code at all. They all exist. If you want to open the door or the chair stuff, then you will, yeah, you have to start doing stuff. But good news is that AI is here. ChatGPT is really good at everything. Just either ask it, what do I do, or have it code it for you. Because at the end of the day, it's C++. And as bad of a coding language C++ is to learn, ChatGPT just do it. Just ask it to create it. It'll do it for you. So you don't have to learn Grasshopper unless you want to do visual stuff. But for this, that's the answer. All right, great. Thank you all for coming. Appreciate it.
Sarah on. So stay tuned, our committees, we will have